Good evening, everybody. Well, good afternoon, good day, I guess. This is for absent kids, so whenever you happen to be watching this. So this is what we did in class. We started out with this to transition from having negative exponents, zero exponents, and the product rule that we learned yesterday. So I'll leave it aside. All right, let's start out here. Here we have a bunch of things being multiplied. What's important is to identify like bases. T to the fifth has a like base of t to the negative seventh. Likewise, c to the negative second has a like base of c to the fourth. When we combine these, we're going to be multiplying t to the fifth times t to the negative seventh. As you recall from our rule, we're going to keep our base of t, and we're going to add our exponents. So 5 plus negative 7. That gives us t to the negative second. Next, we have c to the negative second times c to the fourth. We keep the base of c, and we add our exponents. Negative 2 plus 4 gives us a positive 2. Now, normally yesterday, we would have been done here. We would stop here and we'd say, okay, we did it. But to be fully simplified, we have to have no negative exponents. So right now, we know that we need to handle this negative exponent. From a few days ago, you should remember that this is invisibly over 1 right now. And we're going to ask ourselves, is it going to stay or is it going to go? T to the negative second has a negative exponent, so it's going to go to the bottom and become positive. C to the second, that's a positive exponent, therefore it's going to stay on the top. And our simplified answer is c squared over t squared. We are now going to then find our answer down here. Notice c squared over t squared is a. Where there's a 1, we're going to put a. All right. Number 2, multiplying. You need to identify like bases. 5 to the negative third and 5 squared are like bases. We're going to keep the base of 5, and we're going to add our exponents. Negative 3 plus 2 is negative 1. Since 10 squared doesn't have any like bases, it's just going to come along for the ride for now. Now let's handle our negative exponents. This is all invisibly over 1. 5 to the negative first. Does it stay or go? It goes to the bottom. I could put a 1 exponent there, but I'm not going to because I don't have to. 10 squared has a positive exponent, so it stays. Now we need to simplify further. 10 squared is 100 over 5. 5 divided by 100 is 20. So our most simplified response here is 20. We're going to come around and find 20 here, which is but. So where we see a 2, we're going to put a but. By the way, I forgot to mention that this is creating the riddle that you have to come up with the answer for. So it's not the answer to a riddle, but it is the riddle itself. All right, let's keep it moving. Number 3. A bunch of multiplication. We need to identify like bases. 3, 3, 3, 3. All 4 terms have a like base of 3. So we're going to keep our base of 3, and we're going to add our exponents. So we have 4 plus negative 5 gives us, I don't know how that happened, negative 1. Negative 1 plus 2 is 1. 1 plus negative 4 gives us negative 3, so we have 3 to the negative third. We have a negative exponent, so we need to get rid of it. It's currently in the top. To turn this negative exponent positive, it's got to go to the bottom. And when there's nothing left on top, it's a 1. We can simplify this further by saying 1 over 3 times 3 is 9 times 3 is 27. So our most simplified answer here is 1 over 27, which is it. So under 3, we're going to put it. Let's take a look at number 4. Again, identifying like bases, b to the 12th, b to the negative 15th, gives us b to the negative 3rd, because we kept the base and added our exponents. C to the negative 4th times c to the 4th gives us c to the 0. As you recall, anything to the 0 power is 1. So we could rewrite this as b to the negative 3rd times 1, which is really just b to the negative 3rd. But there should be some major alarms going off here right now, because we've got this negative exponent right here, which is a major no-go. Right now it's in the top. In order to turn it positive, it's got to come to the bottom. And we have a 1 left on top. So number 4 is 1 over b to the 3rd. 1 over b to the 3rd is has. So we'll put a has here. So far we have it has a blank, blank, but blank. So we'll see where we end up. Next one. We've got some new things here, which are called coefficients. These coefficients, such as 2 and 3, have no special rules. They just get multiplied together because it's a multiplication problem. 2 times 3 is 6. Now we need to deal with our like bases. A to the negative 2nd. Oh, there is no a. So what happens? It just comes along for the ride. Then we have b times b to the 2nd. We keep the base and add our exponents. Yes, there's an invisible 1 there. A way that you can remember that is you have 1b here, 2 b's there, for a total of 3 b's. Always think to yourself, how many of this variable do I have? Now we can simplify from here. Notice we have this negative exponent that we need to get rid of. What's the invisible exponent on the 6? Well, that's a positive 1. So 6 to the 1st, does it stay on top or does it go to the bottom? Well, it's positive, so it stays on top. A to the negative 2nd has a negative exponent, therefore it has to go to the bottom to become positive. B to the 3rd is on top, has a positive exponent, so it stays on top. Now I don't have to write this 1 on the 6. I can just write 6b to the 3rd over a squared. Let's find it. 5. 6b to the 3rd over a squared. Here we go. Limbs, which goes here. It has a blank limbs but blank blank. We're getting there. All right, same deal. We have our coefficient of negative 3 and 4, which simply get multiplied together to give us negative 12. We've got a base of x and a base of x. So we have x to the invisible 1 times x to the negative 3rd. We keep the base and add our exponents. 1 plus negative 3 is negative 2. Y here is standing alone. We don't have any other y's, so y to the 2nd just comes along for the ride. Now we need to handle our negative exponents. What's the invisible exponent on the 12? It is a 1, correct. So let's ask ourselves, negative 12 to the 1st, does it stay or does it go? It stays because it's got a positive exponent. Then we've got x to the negative 2nd. Does it stay or does it go? Well, it goes because we need it to turn positive. How about y to the negative 2nd? It's got a negative exponent, so it's got to go to the bottom to turn positive. So our final answer here is negative 12 over x squared y squared. Negative 12 over x squared y squared. Oh, my version isn't right. You guys have it right where the y squared's on the bottom. I don't, though, apparently, but you guys do. So right here is can't. Number 7 is, number 6, sorry, is can't. So it has a blank limbs but can't blank. I don't know what that would be. Maybe you guys do. Okay, here we go again. We've got our coefficients. Negative 5 times negative 2 gives us a positive 10. g to the negative second times g. Keep the base of g, and negative 2 plus 1 is a negative 1. Oops, wrong pencil. H to the negative fourth times h to the second. We're going to keep the base of h and add our exponents. Negative 4 plus 2 is negative 2. Then we're going to say, all right, everything's over 1. 10 has an invisible exponent of 1. Is the 10 staying or going? 10 has a positive exponent, so it stays. G to the negative first has a negative exponent, so it's going to the bottom. And last but not least, h to the negative second has a negative exponent, so it's going to the bottom. Do I need to have this 1 on the g? No, I don't. So 10 over gh squared. Let's find our answer. 10 over gh squared. Right here. Walk. So number 7 is walk. All right, one more word and we have a riddle. Alrighty. We've got coefficients. Coefficients. Negative 3 times 5 is negative 15. A times a to the negative fourth gives us a to the negative third. B times b to the seventh gives us b to the eighth. And c times c to the negative fourth gives us c to the negative third. Now we need to deal with our negative exponents. Be very careful here. The exponent on the 15 is a positive 1. It doesn't matter that the 15 is negative or not. If the exponent is negative is what matters. Since this exponent is positive, it's going to stay in top. A to the negative third has a negative exponent, so it's going to shift to the bottom in order to turn positive. B to the eighth is a positive exponent, so it's going to stay in the top. It doesn't have to move anywhere. And C to the negative third has a negative exponent, so it needs to move the bottom to turn positive. Our last and final clue is negative 15 to the eighth, and this is another one of those situations where you have the correct one, but I don't. Which means we have right here, 1,000. So it has 1,000 limbs, but can't walk. What could that be? I don't know. You tell me. Scan the QR code to figure it out. Hope you guys found this video helpful, and see you soon. Thank you. Bye.